In our previous section, we discussed about static ingress replication, right? So the problem with static ingress replication was that uh, we were facing the scalability issues because we had to do the manual configuration, or we need to define the remote VTAP IPs against the VNIs, right? So as the number of devices increases in our network, we discussed that the manageability will be very difficult because we will be having a lot of manual configuration. So for each VNI, we need to define the remote leaves or remote VTAP IPs. So now we'll see what is the solution to this particular problem. So as I mentioned, you can see on the screen that the solution to static ingress replication is that we can use BGP. Okay, so what BGP is going to do for us is that it is going to distribute the VNI to VTAP mapping dynamically, right? This was our main pain point because we had to do the manual configuration for VNI to VTAPs, right? So at control plane level, so BGP EVPN is going to distribute the VNI to VTAP mapping. And how it is going to do that? It will leverage the type 3 route type. Okay, there are different route types as we discussed also. This is one of them. So when we are using the BGP ingress replication, so it is going to leverage type 3 route type, okay, to distribute the VTAP to VNI mappings. And at data plane levels, so the leaf or the VTAPs, they are going to perform the ingress replication using the VNI to VTAP mapping that was shared or that they received with the help of BGP. So if you worked upon MPLS or if you have studied about MPLS, we know that in the MPLS, for different customers, we use different VRFs. And at each VRF level, we configure the RD value, right? Because in the BGP table, we need to segregate, or there must be something to differentiate between the routes of different VRF. So in this scenario, because see, we are using different VNIs, right? So there must be something in the within the BGP table so that we can differentiate between the information or the IP address or the MAC address that belongs to a particular VNI. So we can differentiate, okay, these are the IP and MAC addresses that belong to VNI, let's say 10.10.10. And these are the IPs and MAC addresses that belong to VNI, let's say 20.20.20, like, right? So like in MPLS, we use, let's say we have VRF1 and the RD is 1:1. Then we have VRF2 with the RD value 2:2. So in the BGP table, uh, we can see the segregation for different RDs. Likewise, here also uh, the we'll see the RD values for different VNIs so that the information will not get mixed. Okay. So there are two options. So you can manually configure the RD value for each VNIs. Like for VNI 10.10.10, you configure some RD value. For VNI 20.20.20, you configure some different value, or you can also use the auto option also. So if you use the auto option, you can see I mentioned that for auto, the RD value will be the router ID or the loopback IP, and then we will be having the colon. Then we'll be having 32767 plus the VLAN number. Let's say you are using VLAN 10. So after the colon, the value will be 32777. If you're using VLAN 20, so for VLAN 20, the value will be 32787. Likewise, for route target, if you're using the auto option, so the value will be the BGPS number and the VNI ID. Let's say the BGPS number is 57391. and the VNI ID is 10 10 10. So your route target will be 57391 colon 10 10 10. Okay, that's for VLAN 10. Now there is more information about how this particular VTAP to VNI mapping will be distributed by BGP VPN. So as soon as the VTAP becomes active, it is going to advertise a type 3 route. Okay, for each VNI it is associated with into the BGP EVPN, so that all the leaf switches, they'll get to know about the VTAP to VNI mappings. So as soon as the leaf switches, they receive this type 3 route, they are going to create a replication list having the VTAP to VNI mapping, so that they can handle the bump traffic accordingly. I also mentioned the command to check this particular VTAP to VNI mapping. So you can run this command, show NVE VNI ingress replication. So we'll see it when we'll do the practical. So the main content of route type 3 will be Ethernet tag ID, that will be your VNI ID, the originating router's IP or the VTAP address of the originating leaf switch, then the inclusive multicast group, because we are not using I mean, so far we did not discuss about multicast, but we can also leverage multicast. See, so far we are discussing about intra-subnet communication, and that can also be achieved using the multicast into underlay. But because as of now we are not using multicast into underlay, so in the route type 3, the value will be set to 0000, and then obviously we'll be having the RD and RT value with the route type 3 for each VNIs. Okay. So before we move to the practical, we can also have a look at the benefit and the see, the one of the benefit is the scalability. So we already discussed about this, right? That is why we are discussing about BGP, because in the static process or the static ingress replication, there was no scalability. Also, we do not need to run any multicast in the underlay. We do not need to have any knowledge of or expertise into multicast. So these are the benefit. Now the drawbacks. So the complexity, because we are we have to configure the different options or different configuration related to BGP. So we are adding the more complexity in our network. So and the troubleshooting will also be a bit difficult. See, it's kind of give and take, right? So if you're using this particular methodology, we do not need to run multicast, and we do not need to have any knowledge of multicast. But if we are running multicast, right, then we can say that okay, we do not need to run any BGP or something, right? So it just depends upon each individual how they see or how they feel, how much comfortable they are in a particular technology, right? So these are the main drawbacks, like the complexity that we are adding, configuring or using the BGP VPN. Then we have the processing overhead, because see, now we are using BGP. Now our devices need more memory, right? Because the BGP requires more processing, the monitoring overhead also, right? Because we need to set up proper monitoring for our BGP also. So just to ensure the optimal performance and reliability. And the last one is the bum traffic handling, because see, if we configure the into the underlay the multicast, so we can easily achieve the intra-subnet communication, or we can handle the bump traffic very efficiently, and we do not need to go into the complexity of BGP. So these are the main drawbacks if you are using the dynamic ingress replication using BGP. These are different commands that we can run. Now let's move to the practical. So in today's practical, we'll be using spine 1, leaf 3, leaf 4, and leaf 5. On leaf 3, both host 1 and host 2 are live. Host 1, as you know, that it is in VLAN 10, host 2 VLAN 20. And on leaf 4, we'll be leveraging only host 4, which is in VLAN 20. On leaf 5, we'll be using host 5, which is in VLAN 10. First of all, I will show you the configuration that uh, that is required for this to for this particular design to work. So I'll go to spine 1, and if I do a show run, so from the BGP perspective, I will show you. So you can see that we have this configuration. We have router BGP, we have the BGPS number, we have the address family, L2 VPN, EVPN, and under the address family L2 VPN, EVPN, we have neighbor 3. The remote AS for neighbor 3 will be 57391 also, because we are using what we are going to do is that we are using this spine as a route reflector, and leaf 3, 4, and 5, they'll be route reflector client. So all the VTAPs or leaves, they will be forming neighborship with spine only. Okay. Then under the address family L2 VPN, EVPN, we are also sending the community, because see, we are using the route targets also, right? So they will be exchanged using the extended community values, correct? Also, we need to give the command route reflector client, because we are using spine as a route reflector. So similar configuration for leaf 4 and leaf 5, right? And you need to enable the feature for BGP also, right? So don't worry about the configuration. I will share with you the configuration of each device, but mainly this is the configuration that is required on the spine. We will enable the BGP feature, right? And then we will, for the L2 VPN, EVPN address family, we need to form the neighborship between leaf 3, leaf 4, and leaf 5. On leaves, we have simple configuration. If I go to leaf 3, if I say show run section BGP, you can see we have simple configuration. We need to enable the feature, and then we have the BGPS number, and under the address family L2 VPN, EVPN, this is the IP address of spine, remote AS number, update source is loopback 0, and both the extended community these commands are configured for the communities, so that we can exchange the route target values, right? So similar configuration is on leaf 4 and leaf 5. Also, if I go to show run interface NVE1, so two more commands you have to configure. First of all, you need to define that the host reachability protocol is BGP. Okay. And secondly, under the member VNI 10.10.10, in the static method, what we had configured, we configured ingress replication protocol static, but now we need to mention BGP. So for both VNIs, I mentioned BGP. Okay. So now, as soon as you configured BGP for these VNIs, so for leaf 3, route type 3 will be advertised into the BGP VPN, so that leaf 4 and leaf 5, they'll get to know that leaf 3 is serving VNI 10.10.10 and 20.20.20. Okay. So to check the BGP configuration, you can run this command, show BGP L2 VPN EVPN summary. Now you can see that we have the BGP neighborship with the spine, right? And similarly, you can say here, show BGP L2 VPN EVPN summary, right? Our neighborship is up with the spine, and same configuration we have applied here also. You can have a look. We have the host reachability protocol BGP under the NVE interface. We have the ingress replication protocol BGP for VNI 10.10.10 and VNI 20.20.20. Now let's try to ping from host 1 to, let's say, host 5. I'll go to, let's say, host 1. If I say show ARP, see ARP is already there because earlier I tested this lab. So let's clear this. Clear IP ARP. Okay. Now we do not have any information about 10.1.1.5. You can do a ping. Now you can see that we are able to ping from host 1 to host 5. Host 1 and host 5 are both in VLAN 10, but you can see that we have a layer 3 core, still we are able to communicate. So it means that our BGP EVPN is working properly. Now we can verify different things. Let's say if I go to leaf 3. So to check the replication list, what was the command? Show NVE interface, show NVE, I think VNI ingress replication. You can see that on leaf 3, we have VNI 10.10.10, and what are the two remote leaf switches who are also part of 10.10.10 VNI 4 and 5. So leaf 4 and leaf 5. So leaf 3 is already having the information, right? Similarly for VNI 20, it has the information that leaf 4 and leaf 5, they are interested in the traffic for VLAN 20 or VNI 20.20.20, right? Now you can verify the same replication list on all the leaf switches. You can see for leaf 4, it has the information about VNI 10.10.10 and 20.20.20 for leaf 3 and leaf 5. You can also have a look at leaf 5. You can see that leaf 5 is also having information about leaf 3 and leaf 4. Other commands that you can run to verify different things is, let's say, show BGP L2 VPN EVPN. You can see that we have the route type 2, right? Because the MAC addresses of the end host, they are exchanged using route type 2, right? So this is route type 2. We have the MAC address of host 1. This is the length, right? It's of 48-bit. And this is the information related to IP because we are working on the same subnet communication. So only the MAC address information is exchanged. There is no, see, type route type 2 can include both information, IP or MAC. So if you are using, if in our future practicals, will see that when route type 2 carry the IP information, you can see here that we have a 216 after the slash. This represents the bit values. If you are having only the MAC address in route type 2, this value will be 216. If you're also carrying the IP address, then this value will be 272. Okay. Now, because if you do a pipe include, you will not see anything with 272 because this is a same subnet communication or intra subnet communication, and we are exchanging only the MAC addresses. You can see that we are having the we were pinging from PC1 to PC5. PC1 is having the MAC address of 1111. PC5 is 5555. Okay, you can also see the route type 3 here, right? I'm on leaf 3. You can see that we have a route type 3 for leaf 3, leaf 4, and leaf 5. So this is how you can check different information. What else I can show you? Let's check with a particular VNI. Show BGP, L2 VPN, EVPN. You can say with, let's say for, you can check this particular table with this with with the VNI separately also, right? For, let's say you also want to check with 2020. Okay. Or you can also check the information directly for the host. Let's say show BGP, L2 VPN, EVPN, and if I pick up the, let's say, the MAC address of host 5. Here you can see different stuff, like as we discussed that this is the VNI ID, right? And you have the RT value. As you know that we discussed about the RT value, that because we are using the auto option, so the RT value is AS number plus the VNI ID. And the RD value, we discussed the loopback IP. Let me see where it is. This one. So the RD value is the loopback IP. So who is sharing this particular information, or this particular host belong to which device? It belongs to leaf 5. So the loopback IP of leaf 5 is 5555. And now you can see we have 32777 because it is for VLAN 10. If you communicate into VLAN 20, you will see the value 32787. Let's try this. Before we try that, let me check what else you can have a look at. Here you can see we have a NCAP 8. It means NCAP 8 means we are using VXLAN. Okay. Okay, so these are the main thing that you can have a look. Now I will show you this automatic RD and RT value for VLAN 20. Let's go to, if we ping from host 2 to host 4. Let's try to ping from host to host 4. I go to host 2, show ARP. It already has this one, so I'll just ping it again. So the IP or the MAC address of host 2 is 222 and host 4 is 444. If I go here and if I again, now if I check for VLAN 20 or VNI 2020, right? Show BGP L2 VPN, EVPN, VNI 2020. We have this information, right? For host 4. And if I check directly for host 4, show BGP L2 VPN, EVPN, and the MAC address. Now you can see the RT value is BGPS plus we have the VNI ID. NCAP, it will always be 8 because we're using the VXLAN. And received label, you can see in our previous example for VLAN 10, there was the 10 that is the VNI ID. And now the RD value I want to show you. You can see here that this particular MAC address is behind leaf 4. So the RD value was loopback IP. and then 32767 plus the VLAN number. VLAN number is 20, so this value is 32787. Okay, so before we close this, I will show you the route type 3. I'll try to capture, okay. What we can do, let's capture Ethernet 1x1 interface on leaf 5, which is going to the spine switch. So we'll see as soon as the VTAP comes up, it is going to send the information, or it is going to send the VTAP to VNI mapping using the BGP EVPN update. So what I can do, I can go to host 5 and let's say I'll share, I'll do interface NV shutdown. Okay. Let's close this. Now again, I'll capture it. Ethernet 1x1. Now I will do a no shutdown. I do a show BGP L2 VPN EVPN summary. If I go here, let's stop it. And I'm looking for this one is the BGP update message. Let's see if we have something into this. So 555 is sending the BGP update message to the spine switch. And in the path attributes, we can see here the NLRI information. And into the NLRI, you can see network layer reachability information here. So it is sending route type 2. No, this is not the update I wanted to show you. Okay, let's do one thing. Let's clear the BGP maybe, and then we'll see. Clear BGP. First, let's capture it. L2 VPN, EVPN. Okay, now once BGP comes up, we'll try to find out the BGP update with route type 3. Okay, open, keep alive. We have one update message here. In the path attributes. So this is for unreachable. This is not the one, okay, because this is when we shut down the BGP. Then we have one update message is here. Let's pause it. I'm looking for the update message from leaf 5 so that we can have a look at the route type 3 message. We have the path attributes. in the path attributes, we have the NLRI information. Now this is the MAC one. I am just also in this one also you can see that it is sharing the RD values and the MAC address information for that particular host. Okay, not in this one. Let's open the next one. This is the NLRI. You can see here, right? So in this particular NLRI or in this particular BGP update, it is sharing the route type 3, right? So in the route type 3, it is sending the information of VTEP to VNI mapping. Okay, you can see that this particular mapping is for which VLAN? It is for VLAN 10 or VNI 10, right? Because you can see here the RD value is 32777. So for VLAN 10, it is sending a route type 3. Okay. If I open another one, you can see there is another one for VLAN 20, right? So it is sending the information that I am interested in VNI 10 and VNI 20. So as soon as the VTEP comes online using the route type 3 and with the help of BGP VPN, it is going to send this information to Spine, and Spine is going to distribute this particular information to leaf 3 and leaf 4, and then once leaf 3 and leaf 4 they received this particular information of VTAP to VNI mapping, they are going to create the replication list so that they can use this particular list when they need to handle the bump traffic. So this is how we can use BGP, or we can dynamically distribute the VTAP to VNI mapping. In our next section, I will discuss about the packet flow, because we did not discuss so far, even in the static ingress replication, how exactly the traffic flows from one host to another. Okay, what will be the Ethernet header? What will be there into the VXLAN header? What will be there into the outer IP header or the outer MAC header? So I will discuss this particular packet flow in our next section. I hope you like this video, and then see you in the next section. Thank you.